Other features, you probably have seen the pingos. This is Piercy Pingo just off the Dalton Highway. This is a particular feature that I found in the Brooks Range. It's a debris glacier, and here's a little bit of a detail of it. This is a permafrost feature because this is a large amount of debris, or a mix of stones and soil and silt, that is kind of sticking onto the surface of a hill. If there would be no ice in there, it would wash away and it would be gone. But the permafrost in the landscape around it and underneath it comes up into this pile of, into this debris, and kind of holds it all together. And often people refer to permafrost features as very stable and moving very slowly over hundreds, thousands of years. But these particular features, because of their unique design, they can also move fairly fast. If I can get this movie. It's not. There we go. This movie is made of the head wall, and it's kind of visible. Back here is the head wall of a debris glacier, and it is May. The snow is disappearing, and you see the surface is slowly collapsing here. A snow event. And not only the surface is collapsing, but also the trees are slowly moving, especially this one will come into view. Some other things we can keep track in this system: air temperature. It's not very accurate, but it gives us a good indication. And some other things that you can see are like the greening of the shrubbery down here. You'll see also that the branches in view here are responding to rainfall events, and so we have a pretty good idea that after rainfall events, and here you just saw a tree fell down the hill from up here, and it just came into view, and now it's slowly moving over, as you can see, and it's falling and being pushed by the mud over. And here's another big rainfall event. You saw the branch go down, and then the mud starts flowing. So there's a clear relation there between these processes that are going on. And the movie is a little bit choppy. It's cheap equipment, and I don't have fancy software to make a better movie out of it. NSF, the National Park Service, they interviewed me about these features, and they wanted to make a better movie out of it, but I haven't heard back from them yet. So, and yeah, there was, for instance, a rock that suddenly showed up, and that rock must have come from way up here because it rolled a long way down the hill. And now you can see that the tree up here is much better into view, and here it's actually being pushed down. Again, big rainfall event. And now in the background, you'll start to see stuff moving even up here. And unfortunately, that tree is also blocking our view of the actual feature. Now you can see all this here moving. It's being pushed out, and the mud comes out even all the way down here. And the funny thing is, the way it looks liquid here, it's kind of like concrete, because I was just a few days after this event, I was there at the site, and I was already able to walk on the mud, which is quite remarkable.
Question, how many frames a day did that camera shoot there?
I think every 3 hours.
Every 3 hours?
Yeah.
Is it difficult to set that up? What kind of camera do you use?
It's actually a camera for game.
Okay.
Yeah, it's one of these game cameras, and you can tell it to set it like a certain interval, or you can tell it to respond to movement. Like if you want to catch a deer, you would set it to movement. And the downside of the camera is that we have not enough control over exposure and all this kind of things, and it actually flashes at night, and it's pretty useless because the feature is too far away. But it eats up a lot of power, and so we run out of power as soon as it gets too dark. That's a pity. I set up a camera at a different spot because it was getting too dangerous here, too close, and there I set it up to take a picture once a day at noon, and so then you also don't see the effect of the different light intensities. So, but that will take longer to make a movie that way. But maybe we'll be able to see other things, different kinds of movement.